look at graphing linear inequalities, and then we will extend that to systems of linear inequalities. These are similar to graphing a line. There are a few things that we have to watch out for, and the first is for our symbol. We want to pay attention to the inequality symbol. If there is no equals underneath, we want to do a dotted line. If there is an equals underneath, we want to do a solid line. So we have to decide that first. Then we are going to graph the line as if the symbol were an equals, drawing either dotted or solid. After we've drawn the line, we're going to pick a test point clearly not on the line. We will test that in the original inequality. If it tests true, we will shade the side that includes the test point. If it tests false, we will shade the other side of the line, which does not include the test point. For our first problem, we have y is less than or equal to 2x plus 1. The first thing you do is look at your inequality symbol. It has the equals underneath, so we're going to use a solid line. That means we are including the line as part of the solution. Next, we will graph it as if it were an equals symbol, except remember we want solid. Right? This one is set up nice in slope-intercept form, so we can pick off our slope. It is 2, which we can do as 2 over 1. Our y-intercept is 1, so 0, 1. We will plot that first, so over 0, up 1. And then from there we will go up 2 over 1. And if we want another point just to make our graph easier, we can go from that point using our slope again up 2 over 1. Now we will draw the line. It's going to be solid. Then we will choose a test point, clearly not on the line. And I would choose 0, 0. 0, 0 is not on our line. We're going to test it in our original inequality. This is x, this is y. So we're going to plug those in. And so 0 into y. We want to know if this is true or false. And 0 into x. So 0 on that side, and on the other side, 2 times 0 is 0, plus 1. And 0 is less than 1, so this is true. That means we want to shade the side that includes the test point. 0, 0 is here, so we want to shade all of that side. So that whole half up to the line is what we want to shade. For our next inequality, we have y is less than 1/3 x minus 3. So our first thing we do is check out our inequality symbol. This time we do not have an equals underneath, so this will be a dotted line. This means that the line is not part of the solution set. So we want to draw it dotted. Now we're going to graph as if this were an equals. Again, we are in nice slope-intercept form, so we can pick off our 1/3 for slope and our y-intercept of -3. We will plot the y-intercept, and we will go up 1 over 1, 2, 3, and we'll do it again just to be able to do a good line, up 1 over 1, 2, 3. Now, when we make our line, it's going to be dotted, not solid this time. Now we have to choose a test point, clearly not on the line. Anytime you can choose 0, 0, that's a great choice because the math is easy. So we are going to test 0, 0 in our original inequality. So we'll plug this y into 0, and the 0 into y, and the other 0 into x, and see what we get. So here we still have 0. 1/3 times 0 is 0, minus 3 gives us negative 3. Is 0 less than negative 3? This time it tests false. That means we do not want the side that includes 0, 0. 0, 0 is here. We do not want this side. We want the opposite side of the line since it's false. So we want to shade on this side of the line. For our next inequality, we have 4x minus 2y is less than negative 8. For your symbol, there is no equals underneath, so this will be a dotted line. Our inequality is not in slope-intercept form this time. We can either move it around to slope-intercept form or we could graph with intercepts. I'll go ahead and move to slope-intercept form, which means isolate your y. So I'm going to subtract the 4x. And I have to divide by negative 2. When you're working with an inequality, if you divide by a negative, remember your symbol is going to flip. So my symbol is going to flip over. Negative 8 divided by negative 2 and negative 4x divided by negative 2. So this gives me y is greater than 4, and you have two negatives here, which will give you a positive 2x. And now my slope is 2, so it will be 2 over 1, and I'm going to use 0, 4 for my intercept. So now I'm going to graph as if it were an equals. So I will plot my y-intercept over 0 up 4, 1, 2, 3, 4. And my slope is up 2 over 1. And it is a dotted line. Then I will try a test point. 0, 0 is clearly not on the line, so I'm going to test it in the original. So 4 times 0 minus 2 times 0. Is this less than negative 8? So I have 0 minus 0. So 0, is it less than negative 8? It tests false. Right, so that means don't shade the side with the test point. 0, 0 is here. We don't want that side. We want the opposite side of the line. So we're going to shade up here. For our next inequality, 5x plus 3y is greater than or equal to negative 6. We check out our inequality symbol. It has the equals underneath, so this will be a solid line. Right. I'm going to move it around to slope-intercept form, so I want to isolate the y. I'm going to subtract 5x and divide by 3. And so when I rearrange it, I have y is greater than or equal to negative 2 minus 5/3 x when it's cleaned up. So my m is negative 5/3. Choose where you want to put the negative. My y-intercept is negative 2. So I'm going to plot that first over 0, down 2. And my slope, it's down 5 and over to the right 3. 1, 2, 3, 4, 5, and 1, 2, 3. So I'm going to connect, and this will be a solid line. Choose a test point. So 0, 0 is a good choice. In our original inequality, so 5 times 0 plus 3 times 0, is that greater than or equal to negative 6? 0 plus 0 is 0, greater than or equal to negative 6. Yes, 0 is greater than negative 6, so it tests true. That means you want to shade the side that includes 0, 0. 0, 0 is here. We tested true, so we want that side.